Now I will discuss about few basic things of climate. Insolation or received EMR is the basic source of energy of the terrestrial Earth. Temperature, pressure and density, these three phenomena are interrelated, and these three phenomena is directly related to the received EMR and the insolation. Warm air is lighter and cold air is heavier. Here the two words lighter and heavier. These two words is directly related to the density. Now the question is, what is density? Density expressed by the capital D, and D is equal to m by V. M stand for mass, V for the volume. We are all familiar with the word population density. So what is population density? Total number of a particular area and divided by that area. That is normally called as a population density. Similarly, in the case of atmosphere, density of the air expresses by the mass by the volume. Okay, here mass expresses in the term of the weight, and area here expresses in the terms of the volume. So density of air is nothing but a mass divided by the volume. Normally, density of the atmosphere directly related to the received insolation, rather received electromagnetic radiation, and it is directly related to the temperature and water vapor. Density is equal to m by V. International Standard Atmosphere state that density of air is 1.225 kg per cubic meter at sea level at 15 degrees centigrade. Here, it's be clear, the density depends upon the standard temperature and pressure. If there is a variation of pressure and the variation of temperature, the density will changes. So density depends on temperature and pressure. International Standard of Atmosphere describe that standard density at sea level at 15 degrees centigrade temperature is 1.225 kg per cubic meter. Warm air retain more heat and it's lighter. Why warm air is lighter? Let's have a look of this picture. It's a city A and city B. A B city is more populated and rather than the A city. Here the intermolecular distance of the point of A city and the intermolecular distance of B city is not uniform. Okay, so population density of city B is higher than the population density of A. Similar analogy is applied for the climate too. Here the intermolecular space of helium is more than the methane, and the intermolecular space of methane is more than the carbon dioxide. So warm air retain more heat, and with warm air there is a trend of decreasing density. That means it increases the distance of molecular distance in between the molecules of the air. So warm air become lighter. And second question is that the water vapor contained air is more lighter than the dry air. Question is why? Water vapor means it contains water, that is H2O. H2O means it's composed of one oxygen atom and two hydrogen atom. Hydrogen is the lighter element and its atomic units, its content the atomic unit of 1. And atomic value of oxygen is 16. So you can explain H2O as two a hydrogen atom 1 plus 1 and one oxygen atom, that is 16. That 1 plus 1 and 16. The atomic value of the H2O, that is the water vapor or water, is 18. 18 is the atomic value of the water vapor. Think about O2. One atomic value of a oxygen is 16. So O2 indicates 16 plus 16, that is 32. Atomic value of nitrogen is 14. N2 N2 signifies that 14 plus 14, that is 28. So obviously 32 and 28 is the higher value than the 18. That's why the water content or water vapor content air is lighter than the oxygen content of air or nitrogen content of the air. That's why water vapor is lighter than the oxygen and the nitrogen. Now come to the normal lapse rate. We are all familiar with the normal lapse rate. In normal condition and in standardized condition, with the increasing the height of the atmosphere, it's limited up to the upper limit of the troposphere, that is called tropopause. On an average height of the tropopause is 16 to 18 kilometers. That height varies from equator to polar zone, and up to the upper limit of the troposphere there is a negative changes, there is a fall of temperature with the increasing the height. Therefore there is a negative relationship with the increasing the height of the atmosphere up to the troposphere, and there is a fall or decreasing trend of temperature that is known as normal lapse rate. The average rate of normal lapse rate is 6.4 degrees centigrade per kilometer. That is expresses by the T is equal to dt by Z. Here T is the normal lapse rate, T is the temperature, D is the unit. So unit of temperature, that is dt, degree of temperature, Z is the altitude. So normal lapse rate expresses by T is equal to dt by Z. It's standardized condition. There is a negative or inverse relationship in between the height of the atmospheres and there is a decreasing trend of temperature. This phenomena is limited up to the tropopause. Now come to the latent heat. Latent heat is the energy absorbed or released by the substances during the change of its physical state. That is known as the latent heat. Normally, the substances changes the phases like solid to liquid, liquid to gaseous, or vice versa. Then the energy is released or absorbed, but without any changing the temperature of the substances. Without, better to say, the body temperature of the substances remains same. That is known as latent heat. In 1762, the British chemist Joseph Black first time introduced the concept of latent heat. Better to say, latent means lie or hidden heat. Uh, it is also normally the temperature expresses in the Kelvin degree centigrade, but latent heat is the amount of energy. So latent heat is expressed by the another unit, that is calories, joule, all these things. Let's have a look of that pictures. Here, this is the solid state. As an example of solid is ice. This is the liquid state. Example of the liquid is water, and that is gaseous state. Example of the gaseous state is the water vapor. When suppose the temperature of the solids of the ice is 0 degree centigrade, and temperature of the water is also 0 degree centigrade, but ice start to melt. Then what happened? Then the latent heat is absorbed, and so ice become the water. And if the water absorb latent heat, then it converted into the vapor without changing the temperature of the water. That is known as latent heat. And similarly, if the gaseous state, that is water vapor changes in the form of water, then the latent heat will be released from the water vapor, and water vapor directly converted to the liquid, and water vapor and the liquid water released latent heat, and that is the minus sign, and they become the solid state. The changes of the phases is related to the latent heat. The body temperature of the substances remains same, but latent heat released and absorbed during the changes of the phases. We are all familiar with the two climatic phenomena. That is the evaporation and condensation. Better to say, in hydrological circle, the two process goes in hand. First part is the evaporation, second part is the condensation. If someone asked you what is evaporation, if the liquid substances absorb latent heat and changes its form, it's converted to the gaseous or vapor form, then that process is called as a evaporation. What is condensation? If the gaseous states of any substances released latent heat and changed into the solid or liquid state, that process is known as condensation. Basically, the hydrological circle, first part is the evaporation part and second part it's the condensation part. Let's have a look. Okay, liquid state of any substances absorb latent heat and changes its form, it converted to the gaseous form, that is known as evaporation. Okay. Normally during the scorching sun rays and due to received insolation, the surface water bodies are dried off and water evaporated. Water start to evaporate. They better to say water absorb latent heat and changes its form without changing the temperature of the water substances. That is known as evaporation. And condensation, the gaseous state released latent heat and changes into the solid or the liquid state. That is known as condensation. Cloud is a good example of condensation because cloud is the gaseous form and we get precipitation from the cloud. So when we get precipitation from the clouds, that the gaseous state changes into the liquid state. So cloud released latent heat and is converted to the rainfall. That is the liquid state. This is the example of condensation. Here latent heat is released by the substances, but the surface temperature of the cloud and water bodies remain same. There is no changes in the surface temperature of the substances. Latent heat is the energy. So latent heat expresses by the unit of energy. It normally expresses by the calories or the joule. Latent heat is the required heat or the energy for an object to change its phases or the state. It's for melting, boiling and freezing. Normally it's for the boiling to vaporization. The latent heat is for the 100 degrees centigrade temperature is 533 calories per gram. Latent heat for vaporization of water is 539 calories per gram and latent heat of fusion of water is 79.5 calories per gram. Latent heat is the energy that required to change the state. It's a unit of mass of material. It's a unit of energy per mass. Energy per unit per mass. It's a unit of energy. Now, what is calories? Calories is the unit of energy. Okay. So, calories was originally defined as the amount of heat required at a pressure of standard atmospheric condition to rise the temperature of 1 gram of water of 1 degree centigrade. In a standardized pressure condition, if someone wants to increase the temperature of 1 gram water of 1 degree centigrade, the amount by required energy is called 1 calories. This is the single unit of calories. Now come to the joule. After 1948, the joule is extensively used as a unit of energy. And there are two methods of used intensively in unit, that is CGS method and FPS method. In FPS method, joule is very popular. 1 calories is equal to 4.2 joule. What is joule? Joule is a unit of work or the unit of energy in the international unit system. It is equal to the work done by a force of 1 Newton acting through the 1 meter. Let's have a look. Suppose this is 45-degree angle and this is this distance, this linear distance is 1 meter. If someone and weight of this substances is 1 Newton. If someone push this 1 Newton to move that substances 1 meter at 45-degree angle, that amount of energy required to remove that substances 1 meter within the angle of 45 degrees, that amount of energy is the unit of joule. Thank you very much.